Okay, so what you are looking at is both the light reaction and the Calvin cycle. And I basically put where it happens, which is the chloroplast. So let's start with explaining the most simplest, which is the light reaction. So basically you have, of course, light energy coming from the sun, and it enters either the photosynthesis 1, which is light required, and this system reduces NADP, or it enters into photosystem 2, and basically what that does is oxidize water H2O. These are found in the thylakoid, and of course that thin layer is the thylakoid membrane. So you have light energy and H2O, water, and then what you get is O2. This is typically what you think of when you say photosynthesis. So let's go on to the Calvin cycle. So the first step is carbon fixation, and CO2 comes in, and an enzyme called ribisco basically is catalyzed by carbon. So the carbon is turned into RUBP, which is a 6-carbon, and since this is unstable, it instantly turns into 2,3-PG, which is a 3-carbon. Step 3 is the 3-PG gets a phosphate, each of them, from ATP. So that's what this is. And that becomes this right here. These are 6. So step 4, the 3-biphosphoglyceride, each of them get an hydrogen ion. It's right here. From the NADPH, it's right here. And it turns into NADPH. No, I'm sorry, to NADP. The molecule loses its phosphate group, and then it goes back to restoring the ADP into ATP. It's up here. So it's going like this. That. There you have a stromer, which basically converts the carbon dioxide that you receive from its outside into sugars. The sugar can be form of starch and can be stored. Sometimes you even get an output of sucrose. So the resulting molecule is called a 3-GP, which is the final goal for the Calvin cycle. Step 6, as mentioned earlier, the main goal of the Calvin cycle is to convert that 3-GP. So only 1 out of these 6 are used for the organic compound, whereas the rest just continues to go back into the cycle. Alright, so there you have it. Light reactions in the Calvin cycle.